Hello everyone. Today I'm gonna talk about Rolldown chunking in the wild. And yeah, I got introduced already, but let me introduce myself again. I'm a senior performance engineer working at Framer. I work on core web vitals and any performance-related problems, really. I'm also a participant in the W3C Web Performance Working Group. So if you have any performance topics, feel free to find me on this conference and ask me questions or like brainstorm performance topics. And of course, if you have questions about this talk, also feel free to reach out. Yeah, I guess I can skip this part. So if you don't know Framer, yeah, it got introduced. We are a website builder and design tool. And the best part is not only you can create websites, but you can publish within seconds. So most of the time, the build process is under a second or so. OK, let's get to the talk. So Alex already talked about this, but what are chunks? And for this, I prepared a small example. So everyone who writes a website probably has a homepage, right? And whenever you write your homepage, you might have JavaScript associated with the homepage. And that's what we call entry points. And a homepage might have another module A and a module B, for example, data utilities or something else. And we might have more entry points. In this case, maybe we are an e-commerce shop, so we have products and we have a checkout. And then a bundler comes in and turns those into bundles. For example, we have the home bundle that contains the home JavaScript. We have the products bundle and the checkout bundle. And what all of those have in common is they import from a common chunk. And that's what a chunk is. So basically, the common chunk then has other modules where other bundles import from. And now this was very simplified. Most of websites don't have only one chunk, they have lots of chunks. And this brings up the question, how many chunks are optimal? And thankfully, we have an answer for this, because Google research looked into Next.js and Gatsby websites, I guess not the most popular ones on ViteConf, but yeah, still. And what they found is this graph. So this was run on at site.co, so that was Vercel's previous homepage or previous name. So it's been a few years, but it's still relevant today. And what we can see is if we look closely, I hope this works. Oh yeah, this works. There's a small curve up here. So somewhere below 100 chunks, we get a sweet spot. And that is exactly 20 to 25 chunks, initial chunks, that struck the right balance between loading performance and caching efficiency. And this is important for later. Next, before I continue, let me say this talk isn't meant to bash on esbuild. Esbuild is a great tool. It's stable and very fast. We've been using it at Framer since many years, and I think we were one of the first ones to adopt it in production. And in my opinion, Ivan Wallace started the race of fast bundlers many years ago, and we are still in the race today. However, it left a void, and that void is something other bundlers could fill. OK, so why do I say I don't want to bash on esbuild? Because it has some issues. And for example, one of those is too many small chunks. So this is a PR that got filed 2 years ago, over 2 years ago, and it's still open. It hasn't been merged, even though it's stable. Some people use it. And yeah, as mentioned, there's a sweet spot in chunks, so this would be a very useful option, right? And I want to put attention to this comment. I think it's the latest comment on this PR. Someone mentions he has 276 initial chunks, and most of them are under 1 kilobyte un-gzipped. That's really redundant. Keep this in mind for later again. Another one. esbuild doesn't have a strict import order. And a colleague of mine, also working on the performance team at Framer, Ivan, filled this over 5 years ago. esbuild doesn't work like the spec wants it to work. And this might not be important for everyone. esbuild might work for you. But for some, this is relevant for security, or in our case, to isolate user code from our runtime code. And finally, there are some other stale PRs. This one got closed because the author got frustrated. But what I want to highlight is those would have been great improvements to esbuild. So I don't understand why there was no activity. Again, not blaming Ivan. He has probably some other priorities and so on. But still, the result of this was author got frustrated. He closed the PR and he told me Alipay, so he was from Alipay, they are using it internally and they forked esbuild as a result. So now we at Framer wanted to achieve better bundling performance. We wanted to reduce our chunks. What do? Fork it? Or should we just unbundle? Or rewrite in Rust like 10x engineers? Let's take a look first why you should bundle. I know Alex talked about this in the previous talk, but what's better than one German telling you you should bundle, two Germans telling you should bundle? Okay, let me get this straight. HTTP 2+ and HTTP 3 do not resolve the need for bundling. And the reason is, once you start splitting one big file or multiple bigger files into lots of small files, you get overhead. And the first overhead is network overhead. So let me quote someone, Harry Roberts, one of the most known web performance experts out there. He worked for pretty much any company you can imagine out there. And what he says is, I'm not going to read the quote out loud, you can do this at home. Once you have one file and you split it into, in his example, 16 files, you increase the amount you pay for round trips by 16. Because whenever a browser requests from the server, there's one request, and then the server sends a response back. And that's a round trip. You download 16 files, you do the round trip 16 times. Second, there's lower compression. Again, quoting someone who worked at Chromium and is now at Shopify, Joaf Weiss. He also leads the web performance working group. What he says is, once compressing one large bundle is always going to be more efficient than compressing lots of small bundles. And finally, you also have the HTTP header overhead. Again, when you send something to a server, it has HTTP headers. When the server sends something back, again, response headers. So you do 16 times, you get 16 times the headers. Next, something that is not so known is the renderer and the IPC cost. So whenever you load JavaScript modules in a browser, in this example, Chromium, you have a cost associated. So first, the HTML parser or renderer has to figure out there's JavaScript to parse, or the script tag is there, and that is called Blink in Chromium. And then it has to pass it over to V8, so the JavaScript engine in Chromium. And of course, since those are two different things, there's inter-process communication cost, aka IPC cost. And once again, Chromium has done a study on this. So at 200 modules, we see there's some browser work to do and some render work, so Blink work. And at 2,000 modules, the graph suddenly changes. Suddenly we have network cost that wasn't there before. So this is not the transmission cost, so not the data transfer. This is just the network process working on the responses. And we also suddenly have IPC cost. And how Chromium puts it is, loading 10,000 1 kilobyte files is 10 times slower than loading a single 10 megabyte file. That's a huge regression. Okay, now you might say, Jacob, I'm not loading 2,000 modules, and I'm also not loading 200 modules. Why am I here? And I have another graph for you. So this is something Simon, linked on the bottom right, did a few years back, also research on how much does it cost to retrieve cached files. So this isn't even about the first visit, it's about the second visit or the third and so on. And what he found is, for example, Chrome OS has an average retrieval time of 50 milliseconds for 5 cached resources. And that doubles to 100 milliseconds at 25. And if we keep in mind the 25 is the sweet spot, we know everything above is gonna be even more costly, and we see it in the graph as well. So now you might say, okay, that's nice, but I don't use Chrome OS, and then I don't know anyone who does. My iPhone 17 Pro loads my website in a second. I have bad news for you, because not everyone on the earth has an iPhone 17 Pro Max, and that's some data collected by Alex Russell, who works at Microsoft Edge, and he collects the average device data year by year and publishes it. And this is from 2024, because there's no 2025 data yet, but the average device out there is here in this graph, a Galaxy A24. And if we extend this line, we see it goes all the way back to 2018. The average device today meets the average spec from 2018. And that doesn't even meet the iPhone 8. So imagine your website on an iPhone 8. That's how the average user feels on your website. So what I'm trying to say is, think about all of your users. And finally, there's also concurrency limits different web browsers, different servers have. And at some point, concurrent, so HTTP2 works by downloading resources in parallel. Everyone knows this. But at some point, when you have too many downloads in parallel, they start queuing downloads, which makes them kind of behave like HTTP1 again. We get waterfalls. That's not something we want to have. And the limit is surprisingly low. And here's Node.js, a very popular server, I guess, amongst us. And it hasn't changed since Node version 10. So after 100 downloads in parallel, they all start waterfalling. And browsers also have some limits, but I hope no one has 1,000 chunks to load. Okay, so to summarize, you should really bundle with all of those arguments. So this is just a summary. Because if you don't, you regress core web vitals, you regress user experience, especially on slower devices and slower networks. Okay, so now we said, okay, we want to keep bundling, right? As a great 10x engineer, like Alex said, there's only one option left, rewrite in Rust. And we had ambitious bundler goals for this. So we wanted granular control over chunks. We want to remove those too small chunks, and we want to have better control, because esbuild doesn't give us the control. We want to have strict module execution order, as mentioned, and we want it to be equal or faster than esbuild, which is quite a challenge. And because I'm lazy, I didn't want to just go and rewrite esbuild to Rust. I've taken a look at other bundlers. And first up is Parcel. Parcel is surprisingly fast, like really fast. I didn't imagine it to be fast, but it's still slower than esbuild, so it wasn't an option for us. RSpec, also a new bundler, quite new bundler. It has a similar API to Webpack, and in my test, it was slower than Parcel, surprisingly. Then next, Farm, that's a Chinese bundler, I guess not so known outside of China. It has a very unique chunking algorithm, but it's slower than RSpec, so again, out. And finally, out of the new bundlers, there's TurboPack, but it's tied to Next.js, so we're not using Next.js, also out. Yeah, what do I do now? Mission Impossible? No, back then I was thankfully following the right people on X, and Ivan Yu was amongst them. So I figured out, okay, in May 2024, I knew Rolldown was coming because I've seen some early tweets about it. And I knew Oxy is fast. It powers lots of very fast Rust tools. So I've also heard Rolldown is going to be fast, or supposed to be fast. And this is the story how we got Rolldown to production at Framer. In August 2024, we figured out that cooperation would make sense because Rolldown could shape Framer's future of bundling, and I could help with all the chunking research I've done and presented here in the previous slides. And you might wonder, August 2024, we now have October 2025. What happened? And that's too much for a single 25 minutes talk, but I can tell you lots of things happened. And I'm pretty sure some of those things, if you ask some of the Rolldown's very smart Rolldown devs, they will tell you fun stories, like bundling 300 megabytes of JavaScript. That's not pretty fun. Anyway, I promised an esbuild versus Rolldown comparison from my POV, so it might not be the most objective one, but that's what I can tell you. So it has a similar API, and in fact, so similar we could just swap out the dependencies, find esbuild, replace it with the term Rolldown, done. Of course, some unique Rolldown additions like the chunking API I will talk about later. There's JavaScript plugin support, as Alex also mentioned. We use it for virtual modules. So for example, we say, okay, if we import from a certain module, we replace it with only stuff we want users to use. And finally, both have JavaScript minification, and there's a difference. No CSS minification in Rolldown yet. So esbuild can minify CSS. And Alex, thankfully, didn't take this away from me, or well, he did. But I want to show you once again, how great Rolldown is. Again, two Germans saying the same thing, never mind. Okay, and then one more thing. Alex mentioned memory usage is similar or something. I can tell you yes and no, because if you bundle two large things, again, 300 megabytes of JavaScript, that's an outlier. Not every Framer website has 300 megabytes of JavaScript, don't get me wrong. And if you also happen to have 500 megabytes of source maps, you see a stark difference between Rolldown and esbuild. So Rolldown is going to take a lot of over 10 gigabyte of memory, and esbuild is going to consume right 9.2 gigabytes of memory. The good news is the Rolldown team is working on this, and once again, I hope no one is really bundling 300 megabytes of JavaScript. Okay, so how do we use those bundles at Framer? Customers can write custom JavaScript. So Framer is a website or a tool where you can come with any JavaScript you want to write. Most commonly, that is React, because any Framer website uses React under the hood. And once again, some customers choose to write lots of JavaScript across all of the pages. So they might not have 10, they might have 300,000 pages. So maybe at that point, 300 megabytes of JavaScript is okay-ish. In any case, we always optimize those pages, because it's important for AI nowadays, because any AI agent out there can't read your content unless you server-side render something. In our case, we use static site generation for this, or called SSG. And finally, our Rolldown process looks like bundling client and server code. So we don't want the server code to end up in client bundles. And once again, I've mentioned this multiple times, strict execution order matters. So our runtime code shouldn't fail if some user writes broken JavaScript in their bundles, basically. Every route also has its own entry point. We lazy load those in the browser using smart heuristics. And also every route has their own dependencies. So once again, they shouldn't be loaded on all other pages if only one page needs it. And the non-trivial question now is, how do you split the code optimally? So how do you land on those 20 to 25 chunks? We know the number, but how do we get to this number? And once again, Google has done research on this, and they established 3 rules. So first, if it's used by some chunks, and if it's below 20 kilobytes, put it in something called common chunks. So the name isn't fixed. You can name it whatever you want, but that's, yeah, just for simplification. Then if it's used on all pages, put it into a shared chunk. And finally, if it's a big library, put it into a library chunk. And before we get too in-depth here, I would recommend to establish a very simple baseline. Start out simple and then start optimizing, so you always know when you regress. And that's the config we use for Rolldown's advanced chunking config at Framer. We have, first of all, a React group, because React updates very rarely. Maybe every half a year, or maybe only yearly. So we want React to be in its own bundle, so every browser or every visitor can cache it for a long time. And I want to put special attention on this thingy here. So we use a regex to say, don't put the React DOM server browser dependency into this client bundle. And that is because Rolldown currently has no exclude option. So if you happen to bundle both client and server code in the same process, you need to tell Rolldown not to bundle the server dependencies into your client bundle unless you want to load 100 kilobyte extra. Then we have our Framer and Motion bundle. So Motion is a web animation library. It previously was called Framer Motion, now just Motion. I can really recommend it. It gets updated more frequently than React, so we put it into its own bundle, but it's less commonly updated than other stuff. For example, our Framer library, that is basically the runtime of every website. Then we have something we call shared library. If it's used by every route, we can put it into its own bundle. And finally, an optimization for bigger sites. So if it has more than 40 routes, that was the sweet spot we found. As mentioned, start simple, then start optimizing, where we say, okay, if it's used by at least half of the routes, put it again into the shared bundle. Next, if you want to then start optimizing, we designed some options for you in Rolldown. And the goal was provide simple, but yet powerful enough options that you can match the capabilities of Webpack's chunking. And first, we have min size. That means don't create a group unless it exceeds a certain amount of bytes. Max size, basically the opposite, but split the group if it exceeds n bytes. Min share count, like seen on the previous slide, only include or like build a group if it's used by a certain amount of entry points. And finally, min or max module size, which means only put modules in that group if it exceeds or if it's below some certain size. Then a word on how we load the JavaScript, because that's also important. We use module preloads, and the JavaScript is served from HTTP 2.3, whatever, from our CDN. And we use module preload for this. And this is important, so that's why I mentioned it specifically. Because if you don't module preload those things up front, your browser will once again waterfall the request. Because if it loads the main JavaScript and figures out there's a top-level import, it will then start downloading the top-level import, and then when the top-level import has more top-level imports, you get a waterfall. So you want to parallelize all of them up front. Okay, a big work for migrating to Rolldown was also analyzing the chunks, because it actually happened that we shipped the server runtime of React to browsers, and that wasn't nice. Thankfully, it was only on our alpha build, so yeah, I can recommend to look at your chunks. And first of all, as quick spoiler, so for all of the Vite users, there will be a talk from Anthony about Vite DevTools later on. And for those who are only going to use Rolldown, like we do at Framer, we have to resort to other things, or at least until Vite DevTools is ready. And we have 2 plugins for this. First of all, Sonder. I think it's not so known, but I will show it later. And Rollup plugin visualizer, because once again, Rollup plugins are compatible with Rolldown, which is great. And finally, Chrome DevTools is also an option, and I think this is commonly overlooked. That's why I want to give it a special look. So here's how Sonder looks. This isn't very helpful to you. It shows our tree map. Basically, we have lots of chunks. This is from our website. The names are kind of hashed, so also not too helpful, but you can put in something in the search, and then you have, for example, I wanted to look up, how much of code mirror are we loading? And I figured out, okay, we're loading 120 kilobytes for parsing HTML. Okay, I guess there's room to optimize. And here's how DevTools works. So first of all, open DevTools, then press Control-Shift-P or Command-Shift-P, I think, and then show coverage. And then you get at the bottom some fancy-looking coverage graph where you can visualize how much of your bundle is unused. And any ratio below 50%, so in other words, if more than 50% of JavaScript is used in your bundle, it's, I think, a good ratio. And it even shows you in the sources which function is unused. So if you really want to be a performance detective, you can look it up and figure out, why is this function in my bundle, even though I'm not using it? And the answer might be sometimes, okay, you need to scroll down your website and suddenly it's used, so that might be simple, or do a navigation. But sometimes it's just there because something is initializing it, but they're not using it. In any case, there's also other good news. If you want to follow a discussion about an esbuild-like meta file that unlocks some other things, I can point you to issue number 6425. And once we have a meta file that is esbuild-like, we have lots of more options to analyze chunks. And that starts from Angular's Hawkeye to bundle body, esbuild analyzer, bundle size analyzer, esbuild bundle analyzer, and that again unlocks support for Webpack, bundle compare, and even RS doctor from RSPack. So once we have this, we unlock pretty much the entire toolchain. And next thing, Rolldown also has an integrated option to analyze chunks, and that is called attach debug info. If you turn it on in the experimental options of Rolldown, you will get something on top of every chunk. And that tells me, okay, this chunk has been spilled out because I put it, or because I have it in my group called Framer. And then there's also something called common chunk. So this tells us, okay, an entry point points to this chunk, and another module, and another module, and another module. And once you remove all of those, the chunk disappears. So that's a good info if you want to minimize your chunks. Okay, so now you might wonder, all of these words, what did it result in? And here are some basic stats about our improvements to chunks. So we pretty much improved every percentile, including P99, quite some substantial drops. And one of the most important things is our median JavaScript size dropped by 36%. So users download 36% less JavaScript by better minification, by better chunking. And this results in a 4% average improvement to LCP for websites between 1 to 2 megabytes of JavaScript, and a very high improvement of 41% to LCP for websites with 2 or more megabytes of JavaScript. And finally, we found 11% faster LCP at P90 across all Framer sites. And P90 means we gave a little love to slow devices and slow networks. To summarize everything, I think the cooperation with Rolldown yielded to a fast, stable, and capable bundler, and that is a win-win for everyone, for us at Framer, for our customers, their visitors, the Vite community, and the entire web. Thank you.